Hello everyone, and welcome to this exciting tutorial on the decimal number system and its conversion to binary, octal, and hexadecimal. I am Louis Justin C. Saturno, and together with my groupmates, Mark Daryl Hermosa and Roland Jonas Macalanda, and today, we're going to demystify the world of numbers. To begin, let's understand the foundation of our numerical world, the decimal number system. Decimal, often referred to as base 10, is the system we use every day. It's built on the power of 10, and every number can be represented using 10 unique digits: 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. But here's a cool fact for you. The decimal system is so versatile that it is everywhere around us, from your phone numbers to your bank balance, and even the time on your clock. Decimal numbers are integral to our daily lives, and it is the universal language of numbers, making it easy for us to communicate and understand quantities. Now that we have explored the decimal system, let's delve into the world of number system conversions. You see, our digital world relies on not just decimal, but also binary, octal, and hexadecimal systems. These different bases allows us to store, communicate, and process information more efficiently.
Hello guys, my name is Roland Jonas Macalanda. So ang tatalakayin natin ngayon is paano gawin ang decimal to binary. So ang decimal, gumagamit siya ng base 10. Habang sa binary, gumagamit siya ng base 2. So ang ibig sabihin ng base 10, ang ginagamit nito is 0, wait lang, 0, 1, 2, 3, 4, 5, 6, 7, 8, 8, 9. My bad, hindi perfect. Wala namang perfect na tao. So, ang sa binary, gumagamit siya ng 0 at 1. 1, 0. So, for example, kung paano natin gawin decimal to binary is, sample ng decimal is 18. Paano natin gawin? So, ganito lang. Gumamit tayo ng 1, 2, 4, 4 do, 8 do, 4, 8, 16, yan. Huwag natin sobarin. Siyempre, i-add natin to para masakto. So, 16. Pwede. Pwede mo may 16 plus 8. Hindi pwede. So, 0. So, 16 plus 4, 0 pa din. 16 plus 2, so 18. Pwede. Tapos, ganun, 0 na. So, ganito lang guys, kadali. Maliit na 2. Yan. So, ganyan lang kadali guys. So, another example. So, ang gawin natin is medyo malaki ang 42. 42. So, kanto din. 1, 2, 4, 8, 16, 32. So, 42, gawin natin binary. So, 32 pwede. 32 plus 16, hindi, sumobra na. So, 0. 32 plus 8, pwede. Siyempre, maging 40. So, 40 plus 44, hindi pwede sobra. 40 plus 2, pwede. So, hindi na natin kaninin. Yan. So, ayan guys. This is how you make decimal to binary. That's all, and thank you.
Hello guys, today I'm going to teach you how to convert decimal to octal conversion from base 10, base 8. First, you're going to divide the number by 8 until the quotient becomes 0. For example, we're going to convert 92 base 10 to base 8. The solution would be 92 divided by 8, the quotient is 11, and the remainder is 4. Now, the next step, you're going to take the 11 and divide that by 8. And now the quotient is 1, now the remainder is 3. Then the next step, 1 divided by 8, quotient is 0, the remainder is 1. Now write the remainders from bottom to top. So with that, 92 base 10 is equal to 134 in base 8. You try. Convert 236 base 10, base 8. Going to give you a few minutes to try this out. Pause the video if you want. Now here's the solution. 236 divided by 8, the quotient is 29, remainder is 4. Then 29 divided by 8, quotient is 3, remainder is 5. 3 divided by 8, quotient is 0, remainder is 3. Now write the remainders from bottom to top. 236 base 10 is equal to 354 in base 8. Thank you guys for listening.
Before we proceed on the conversion part of decimal numbers into hexadecimal numbers, we have to take note that 0 is equivalent to the hexadecimal number 0. 1 is 1, 2, 2, and so on until we reach the number 10, which is equivalent to the hexadecimal A. 11 is equivalent to B. 12 is equivalent to C. 13 corresponds to D. 14 corresponds to E. And 15 corresponds to F. I forgot the number 9, which is also equivalent to 9. And that's all. We have to be familiar on this equivalence so that in the conversion part it will be easier for us to convert. Before we proceed on the conversion part, we have to take note of this verse. Decimal 0 is equivalent to hexadecimal 0. 1 is equivalent to hexadecimal 1. 2 is equivalent to hexadecimal 2 until we reach number 10, which is equivalent to A and not 10. Then we proceed to decimal 11, which is equivalent to B. 12 is equivalent to C. 13 is D. 14 corresponds to E. And lastly, 15 corresponds to F. Oh, I forgot to add number 9, which is equivalent to also number 9. So if we would count all the numbers here in hexadecimal part, 0 to 9, which is 10, and we add the remaining 6, which is 16 numbers. So here, we need to convert the decimal number 200 to its hexadecimal number. So the first step is to write 200 and divide it by 16. We need to divide 200 by 16 and get its remainder. So 200 divided by 16 is 12, and its remainder is 8. Now, we have to get this number 12 and write it on the left part. And we need to divide this again by 16. So 12 divided by 16 is 0, remainder 12. So we're done on the first part, and now we proceed to the second part of this step. So we write this from left to right, 12 and 8. So 12 is equivalent to C, and 8 is equivalent to 8. So remember that in the before we proceeded in the conversion part, I told you that numbers 10 to 15 have different equivalences in its hexadecimal form. So 10 is A, 11 is B, and 12 is C. So the hexadecimal number of 200 is equal to C, 8. And don't forget to add its base 16. So we could identify if it is a decimal number or a hexadecimal number. So here is the answer for number 1. So here is another example. Let's try another number which is larger than the previous example. So here we have to convert 1063 to its hexadecimal form. So remember, we have to divide this number by 16, okay? So let's divide it by 16. Divided by 16 is equal to 66. And its remainder is 7. So we have to take this number 66 and put it on the left part. So again, divided by 16, and it is 4, and the remainder is 2. So we have to take 4 on the left part. 4 divided by 16 is equal to 0. Remainder 4. So I forgot to mention that we should stop dividing when we reach the number 0. So here we stop we stop in the third step, or the third iteration of division. So here we have to write it from bottom to top. 4, 2, 7. So in these numbers, we didn't see any number from 10 to 15. So we do not need to convert each of them. So 47 is the answer. And also don't forget to add the base 16. And the answer is 427, hexadecimal number. To make sure that you have understood the process of converting decimal numbers to hexadecimal numbers, you need to try solving this decimal number 831 to its equivalent form. To make sure that you have understood the process of converting decimal numbers into hexadecimal numbers, you need to solve this. Convert the decimal number 831 to its hexadecimal form. So we will give you 5 minutes to answer this, and later we will check your answer to see if it is correct and to see if you have understood the process correctly. Alright, time is up, and let's check your answer. So 831 divided by 16 is equal to 51. Remainder 15. Take this number 51 and divide it by 16 again, and 3. The quotient is 3 and its remainder is 3. So take this number 3 divided by 16 is 0, remainder 3, and write it from bottom to top, left to right. 3, 3, 15. As you can see, we have the number 15, which is equivalent to F, and number 3 and 3 remains the same. So the answer is 3F. The decimal number 831 is equivalent to hexadecimal number 33F. So if you got this correct, clap for yourself.